So far we've been studying linear functions and absolute value functions. This chapter is going to be about quadratic functions. So quadratic functions look like parabolas. They can open up or they can open down. And a quadratic function looks like this. F of x or y equals ax squared. This is the quadratic term. The letter in front of x squared, a, is the constant, or the number in front of x squared is the letter a. The number in front of x is the letter b. It's called the linear term, and the number that doesn't have an x value is called the constant term. So usually in standard form we write them in order from highest to lowest degree. So example 1, determine whether each is a quadratic or linear function. Identify the quadratic, linear, and constant terms. So first we're going to write these in standard form by getting rid of parentheses. So it's going to be y equals 5x squared minus 40x. So this is going to be a quadratic because of this x squared term. So this term is the quadratic term and this term is a linear term. So now the second one, I'm going to distribute this. So it's f of x equals 3x squared minus 15x minus 3x squared. So I can simplify this and see that these two cancel out. So your function is just going to be f of x equals negative 15x, which is just a linear function. So this is the linear term. Okay, so the parts of a parabola, as I've already talked about, are you can have the vertex. So the vertex you can find by doing opposite of the b divided by 2a. That's going to give you your x value, and then what you're going to do to find the y value is you're going to substitute the negative b over 2a back into the function f of x. So a vertex on a graph looks like this. In this case, that's the maximum of the parabola. You can also have the minimum value of the parabola. But whatever it is, it's an ordered pair, so it's going to have two numbers associated with it. It's going to have an x and a y. So to find the x, you do opposite b over 2a, and then you plug that number in to find the y. The axis of symmetry is the equation. It's an equation, so make sure you write x equals. It's a vertical line that is a symmetry line of the parabola. So if this is your line of symmetry, it has to cross through the point of the vertex. So it's x equals negative b over 2a. So axis of symmetry, it's a vertical line, and you need to write in the equation for it. The y-intercept is in a parabola where it crosses the y-axis. So to find the y-intercept, what you need to do is set x equal to 0, because right here x is 0, and see what the function f of 0 is. So when you plug in f of 0, you're going to get the y-intercept. Okay, example 2. Identify the vertex and axis of symmetry of each parabola. Then identify points corresponding to P and Q. So your vertex on this one, this is actually a minimum. And I'm going to write the ordered pair 1, negative 1. The scale's only going up by ones. The corresponding point of Q is, well, now I need to do the axis of symmetry. The axis of symmetry is this vertical line, x equals 1. And then Q is on the opposite side of it. So if Q is right here, Q prime, all right, Q prime is going to be 0, 0. P prime is going to be right here, and that value is going to be 3, 3. So these points, these corresponding points, are equidistant from the axis of symmetry. And then over here in the vertex for letter B, this right here is negative 1, 2. This one has a max, by the way. The axis of symmetry has to be the equation x equals negative 1, and I'm going to draw it in. It's a vertical line. Make sure you have the equation. And then my p prime is going to be over here. It's going to be, p prime is going to be at 0, 1. And then q prime is going to be at negative 3, negative 2.